Hello everyone, good morning and good evening. Consider your time zone. In this video, I will demonstrate how you can analyze antibody titration in flow cytometry by using FlowJo. So we all know flow cytometry, to get a good data, you start with a right panel or you design a very good panel considering all the thumb rules, like high or low expressed antigen. You choose low brightness trim fluorophore to high brightness fluorophore. You make sure you definitely have a very less spillover as much as possible, and considering all the co-expressions marker, choosing the right clone of antibody. But I'm not gonna discuss how you can make a right panel today. I rather want to talk how you want to do the titration and you analyze the which concentrations of antibody should be your working concentration, because antibody titration probably you want to do fasting in your lab for the flow cytometry, because the right concentration of antibody will help you to minimize your background, and at the same time it will maximize your specific signal detections. So you definitely want to consider the first thing in your lab. I'll show you today the titration of APC 750, which is a tandem dye, and it's considered dim fluorophore compared to the other fluorophore in flow cytometry. And as I said, it's a tandem dye, means it's combined APC with longer wavelength, giving it less emission in the far red or near infrared range 750 nanometer. And due to its longer emission wavelength, APC 750 typically has lower brightness compared to the other commonly used flow cytometry fluorophore like APC, PE, and FITC. Remember, APC and APC 750 is not same. So I'll move to the FlowJo analysis. Here is the FlowJo, and I already have a few samples with different concentration of APC 750 fluorophore for one of the marker, which is not main thing here to discuss. I'll just focus on the APC 750 different concentration. So to start with that, I'll just initially do some gating. So you know how to gate, but I will do from the beginning. So this is the raw data from APC 750 0.5 microliter. And first thing I will do, I'll choose the lymphocyte gating. So this is my lymphocytes. And the second thing I typically do, I find out my single cells from double cells. And typically single cells is separated by area versus height. So I always go side scatter area versus side scatter height, which gives me single cells. So for now, this is done, and I'll just apply this gating to all of my sample. So I can uh, hit lymphocytes and single cells by pressing Control in the keyboard. So now I have lymphocytes and single cells, and I can apply this gating to all of my other samples. So how I can do that? I can just right click and do copy analysis to group. So now my all the samples have same gating. So I want to show at first you how I can do the concatenate, which will give you the good visualizations of APC 750 in one plot. And to do that, you just have to select single cells. So you can press Control in your keyboard and you can go single cells from each of the sample, or you can just press Control, Shift, and E. So now it selected all the single cells from all the samples. And under the file option from your FlowJo, you'll see the export slash concatenate. So we'll go that option and we'll choose the export concatenate population. and you'll see that this window will pop up and you have to go concatenate. And if you don't see the advanced option under concatenate, you have to click here. Since I already opened it, so I already have a advanced option open. And now you have a choice. You can do all the uncompensated or all compensated parameter. So, and you can also change the name. So I'll just write the demo concat, and I'll go with all the uncompensated parameter is fine for me right now, just to show you how it looks like. And simply I'll just hit concatenate, and it's already completed. And I'll choose existing workplace, sorry, existing workspace, and I'll close the window and I'll cancel it. So now I see I have a new concatenate single cells here. And if I just click these single cells, I will choose sample ID from the x-axis. I will change my scale, which is now look like this. So I'll just change the scale to get a better visualization. And I'll choose APC 750 area since I'm doing APC 750 titrations. Now I see at APC 750 at different concentrations plot. So the first one is zero point 0.5, the next one is 1 microliter, 2 microliter, 5 microliter, and 8 microliter. So you really cannot judge from here. It's just for your visualization. Definitely you can null out by your the better resolution, and but it really cannot give you the conclusion point. So how you can choose which concentration is better? So to do that, you have to go for stain index. So I'm not gonna discuss the calculation of stain index. I had a PowerPoint slide here. You see that the calculation is very simple here. But even though you don't know the calculation, how you to do that, you can just use FlowJo software and you can do it very easily. So to do that, I'll just do a little more gating. So I'll go the first option, which is zero point 0.5 microliter. I'll go the single cells, and here I'll actually choose the gating. So in x-axis, I'll choose APC 750 since I'm doing APC 750, and I see I have two population, and I'll do gating. So this is my APC 750 negative, and the next one is APC 750 positive. So this is my negative and positive gating, and definitely I want to apply this same gating to all of my other samples. So I'll just select both of this option, and I'll just copy analysis to group. So now I have APC 750 positive and negative, same gating to everywhere. Just for visualization, I want to double check that my gating is same. How can I do that? I will just click this arrow, in the right corner top of my plot, and I'll see this fine. You see now it's zero point 0.5 microliter. So if I click here, it's now showing 1 microliter, and I see 1 microliter, my gate is okay. So I'll just check all other microliter, other samples. So 2 microliter is fine, 5 and 8 is fine. So my gating is fine. And what I'll do, I'll find out the stain index for all the samples with different concentration of APC 750 fluorophore antibody. So I'll just click single cells. I'll go workspace, and under plugin option, I'll find stain index, and the window will pop up, will suggest me to save, and I have to save this data. Let's say I saved it somewhere in my computer. And if I save it, this window will pop up. So I can do the multiple staining index at the same time, but since I only have one, so I'll not select this checkbox. Rather, I'll go the next option, stain index parameter, and I'll click here and I'll choose APC 750A for area. And the next one is positive gate. So I know my positive gate is APC 750 positive, and my negative gate is APC 750 negative. And that's it. I'll just press OK. And I see that a few window popped up and I automatically see one histogram and a calculation. I will jump to this calculation since I'm focusing on the staining index and I'm looking for a number, because number will help me to judge which concentration is better. So, and you see the formula here, and you don't have to worry about the formula. The formula is the same formula I just showed you. And you can go to visualizations, you can put a heat map for formula. However, that's not my main concern. My main concern to create a table. And if I create a table, I see that I have a few stain index number against all the concentration starting point zero point 0.5 to 8 microliter. And I see that the highest value is here 1 microliter, which is 81.6. So even though in 8 microliter of antibody I used, I have a stain index for 8 microliter is 55. So the more antibody doesn't mean that you have a very good results. And you cannot also use a very less concentrate of antibody. So you need to find out a right sweet point of your antibody concentrations. And it is not an arbitrary number. So my case, I see that 81 stain index value against 1 microliter of my antibody. So I will consider the right concentration of antibody is 1 microliter here. And I'll use this concentrations for rest of my experiment. And I'll do the same thing for other channel or other antibody with fluorophore, uh, considering whatever antibody or experiment I have in my lab. That's all your results. You